on a topic called as the haloalkanes and the haloarenes, in particularly for the 12th class students or the PUC second year students. Now, the first question, the given compound, this is the given compound, okay, is an example of, this compound is an example of, here four options are there: the benzylic halide, the arylic halide, the allylic halide, and the vinylic halide. Which is the compound? Now see the compound carefully. If you see the compound, then you can say this carbon, particularly concentrate this carbon. This carbon is sp3 hybridized. sp3 hybridized because to the carbon the halogene is linked, and hence it is sp3 hybridized. To this carbon, the other carbon which is linked is double bound. This is you have to see. Okay, this is double bound, carbon carbon double bond, and because of that reason, the answer C is the right answer, and it is the allylic halide. It is the allylic halide, and that is the answer is the C. Next, the correct sequence of bound enthalpy of the CX bound is the bound enthalpy. Already you had studied what is called as the carbon fluorine bound, carbon chloride, carbon bromide, and carbon iodide. Already I had told you that electronegativity goes on decreases, and hence the bound length goes on increases. The bound length is goes on increases. Now as the bound length goes on increases, the dissociation enthalpy goes on decreases. The carbon fluorine have a highest enthalpy, whereas the carbon iodine is having the less enthalpy. So we can see that the option C, the CH3, okay, methyl fluoride, and then the methyl chloride, methyl bromide, and methyl iodide. It's goes on, which is okay, the bound enthalpy, and here you can see that. So that is what is the answer for this. Now the next question, that is a third one. The product of A and B obtained in the following reaction respectively are the products of A and B obtained in the following reaction. So this is the reactions is given, and what is forming. One is the PCl3, another is PCl4. When the alcohol reacts with, okay, this is alcohols or phenols, you can say, they react with the PCl3, it gives the reaction, it gives that A is nothing but H3PO3, H3PO3 it gives, and when it is react with the PCl4, that the B is the POCl3. the phosphoroxy chloride or trichloride. And hence, the option D is the right option. Option D is the right option for this reaction. The A is H3PO3 and the B is POCl3. Okay. The next question: which of the following reactions can be used for the preparation of the alkyl halide? So there are four reactions they had given. Four reactions they had given. And in the four reactions, which is used, which reactions are used for the preparation of the alkyl halide? Preparation of alkyl halide. First one, you can see that the ethyl alcohol, okay, in the presence of HCl and anhydrous, what is called as the zinc chloride. Now this is a primary alcohol, this is the tertiary alcohol, and this is a secondary alcohol, the third one. And the second is also a primary alcohol with HCl. Now in this case, the second is actually not forming what is called as carbocation. Okay, not forming the carbocation, and hence all other are forming. Therefore, the 1, 3, and 4 are follows, okay, are used for the preparation. 1, 3, and 4. 1, 3, and 4. So the option A is the right answer, and because the second is not possible, because here it is a primary alcohol, and without the anhydrous zinc chloride, it is not forming what is called as the alkyl halide. Okay, this is the question number 4. Now, here the question number 5. Which of the following is suitable to synthesize the chlorobenzene? Which of the following is suitable to synthesize the chlorobenzene? Here the option is given. Okay, A, B, and C. Let's see how we can prepare. Okay, now from the benzene, we can prepare like this. It is benzene. When it react with the chlorine in the presence of, okay, so anhydrous ferric chloride, anhydrous the ferric chloride, what you are getting is, you are getting this compound. You are getting this, and that is the chlorobenzene. This is the chlorobenzene. Okay, now this is the reaction in the presence of anhydrous, what is called as here. So, and because of that reason, this is that option D is the right answer to forming or synthesize the chlorobenzene by using the benzene. Now we'll move on to the next question, and that is sixth question. The compound that will undergo SN1 reaction with the fastest rate is the compound which is undergo, okay, SN1 reaction with the fastest rate is. Now here there are four the compounds are given. The first important is that when the SN SN1 reaction is forming, the compound must be formed. Okay, that carbocation is has to be formed. The secondary carbocation has to be formed very fast, and because of that reason, this compound, I'm just writing that, see, this compound CH CH3 Br. This is the compound which easily forms secondary carbocation. Carbocation. This is a carbon which is secondary carbocations. Secondary carbon. This is secondary carbon, one hydrogen. Okay, and it is a secondary carbon, and hence it forms secondary carbocation very easily, very fast, and uh, not only that it also undergo the resonance as per the stability, and because of that reason we can say that the answer D is the correct answer. Okay, that is the compound, this compound which undergo the fastest SN1 reaction. Next is ninth one. The major products A and B formed in the following reaction sequence are. These are the option as given, and this is the reaction. This is the reaction, and in this reaction, which are the major product A and B is forming. So I'm just writing here. This is a CH3OH. Okay. The first is phosphorus tribromide, tribromide, and here the what is called as the nucleophilic substitution is taking place, and hence you are getting this product first, and that is here BrCH3. It is nucleophilic substitution you are taking, and the OH is replaced and substituted by the bromide you are getting, and that is the first. And the second step here he has given, that is alcoholic alcoholic KOH. Alcoholic KOH eliminates the the hydrogen as well as the halide groups, and here halide is the bromide, and hence what you are getting here is you are getting this compound, and that is called as the elimination reaction, and this is the product A and this is the product B. So where you can see that the product A and the product B is there, and that is the option. The A is the right option, right? Okay. Option A is the right option. That is for the seventh one. Okay. Next, we can go for the eighth one. Which amongst the following reaction of the alkyl halide produces the isonitrile as a major product? Isonitrile as a major product. So choose the most appropriate answer from the options given below. Options given below. So There are four reactions they had given, the four reactions, and out of the four reaction we have to see the which is the right option, which gives you what is called as isonitrile. First you can see the KCl. Okay, KC, KCN, I'm sorry, KCN. KCN is the ionic compound and hence it gives a large number of the cyanide ions in the solutions. And in the cyanide ion, both the nitrogen and carbon, both are eligible to give a pair of electrons. And because of that reason, you are not getting what is called as isonitrile compound. On the other hand, if you just see the one more is that is silver cyanide. And a silver cyanide is a compound, called as the covalent compound. And because of that reason, in this cyanide, only the nitrogen is having the ability to give a pair of electron or donate a pair of electron. And because of that reason, this is eligible, or the that is the silver, the cyanide is having the capacity to form the isonitrile compound, and hence the option A, that is only B, that is this reaction I'm writing here, the reaction that is so Rx plus AgCN, which gives R okay, R NC plus AgX. So this is having the capacity, or this is having the ability. The silver cyanide is having the ability, and because of the that reason, the option A is the correct option. Now go for the next one. Ninth one. The reactivity order of the halide for dehydrohalogenation is, okay, dehydrohalogenation is the order of the halides. Okay, once again here you can see that the halogen, that is fluorine to chlorine to bromine to iodine. Now the fluorine is a small, okay, small in size compared to the iodine. As go down, the size goes on increases. As the size goes on increases, the bound length is also goes on increases. The bond length is goes on increases. So the carbon fluoride bond is the smallest bond, whereas the carbon iodide bond is the largest bond. And because of that reason, well, the bond length is more, whatever the enthalpy is required will be less. The bond enthalpy which is required is less for this compound compared to the fluoride compounds. And because of that reason, the Ci is more reactive, and because of that reason, the option B is the right option, that is for the dehydrohalogenation.